the equivalent of 2 shots, like to put it into the college vernacular. So people are drinking a small volume, about 80 milliliters, not a whole lot. It's usually like 2 or 3 swallows. And that volume was said to stop and even prevent cramping in some athletes. And so what we showed in multiple studies, we did it in hydrated people, dehydrated people, exercise, no exercise. What we showed was it doesn't change the bloodstream. Sodium, potassium, calcium, magnesium, osmolality, plasma volume. It doesn't change any major blood characteristics. But what does seem to be an interesting phenomenon is it does seem to stop muscle cramping faster than deionized water or drinking nothing at all.
Kevin, everyone that has experienced exercise-induced muscle cramps before have probably asked the question, why did I cramp and what can I do to elevate it as fast as possible when it strikes, right? And perhaps more importantly, they've also wondered what they can do to prevent it because, well, it sucks.
Yes.
With your help today, I hope we can get some clarity on some of those questions. So let's start from the very top, right? With the mechanistic fundamentals, what exactly is a muscle cramp and what's happening inside the muscle when it actually cramps?
So great questions. And thanks again for the opportunity to join you today. And thanks to all of our listeners for engaging in the conversation, hearing the thoughts on muscle cramping. So the first question, what is a muscle cramp? So a muscle cramp is a involuntary, painful contraction of a skeletal muscle, usually during or shortly following exercise. Now, the majority of our conversation today is going to revolve around exercise-associated muscle cramping. And so just be aware that when I talk about muscle cramping or I drop that term, I'm specifically referring to exercise-associated muscle cramping. We certainly know that muscle cramps are a symptom or sign of underlying disease like hypothyroidism or Machado-Joseph's disease, even diabetes. But those are signs of an underlying medical problem. What we're talking about today are the painful involuntary skeletal muscle contractions that occur during or after exercise in normally healthy individuals. And so the only thing that appears to be wrong with these people is that they get a cramp during exercise or due to some kind of hard labor. And so we think the cause of them really comes down to 2 or 3 major camps. Historically, we've always kind of said that they're a result of dehydration or electrolyte loss. In fact, if you were to survey medical professionals, even today, about 90% of them would say that cramping is a result of dehydration or loss of sodium or potassium or some of the major electrolytes. The other side of the fence, the more recent research in physiology and muscle cramp research would suggest that cramping is more of a result of changes in the nervous system, that something has gone awry within our nervous system, and that might be due to several different factors. And so I proposed the most recent theory for why cramping occurs back in about 2022, and I very cleverly called it the multifactorial theory. And just to give people the idea that there's essentially more than one way to get a muscle cramp during exercise, whereas the earlier theories kind of focused on just one thing, like just dehydration or electrolyte loss, or the other predominant theory that came about in the 1990s, early 2000s by Martin Schwellnus was more related to fatigue. And so as time progressed and as research progressed, we certainly know that people get muscle cramping when they're hydrated, not just when they're dehydrated, right? We have people who get cramps, just sitting down at a table and they move their legs in a wrong way and they get a muscle cramp, or they do something that causes the cramp when they're not dehydrated, when they haven't lost a lot of electrolytes. But we also have people who get cramps during exercise on some days, but not others. Are they not fatigued on those days, or are they more fatigued on those days? And so both theories, kind of the neuromuscular fatigue hypothesis and the dehydration hypothesis, both had kind of problems explaining a lot of the research that we had been seeing in athletes and physically active laborers, those types of folks. And so again, I proposed the multifactorial theory, which really says 2 major things. The first is that everybody has their own recipe for why they get a muscle cramp during exercise. And so just like there are 100 different pasta sauces that you might be able to find at a grocery store, there might be 100 different ways for an individual to get a muscle cramp during exercise. And then the second major proponent of my theory says that everybody has their own individual threshold for where they cramp, right? And so that threshold might be modifiable up or down. So it's easier for you to cramp or harder for you to cramp based on things that you might have done in the last 24 to 48 hours, right? And so everybody's got their own recipe for why they cramp, and that recipe might differ. Your recipe might be different than mine. And then our recipes are modifiable based on what we do in our lives up into that moment in time. And so I think that kind of theory better explains why some people cramp on some days and not others, why some interventions work for some folks and not others. Because for the last 150 years, we've treated muscle cramping like this not very serious thing. And we'll just tell people this blanket advice, right? Like just drink more or take in more salt or stretch, right? We give this one-shot recommendation, but it's a much more complex physiological phenomenon than what people have made it out to be.
Okay. So you mentioned nervous system. Is that where the root cause of, I don't know whether root cause is the right word, but of a cramp comes from? Or is it muscular, something to do with the muscles itself? Or is it a combination of both?
Yeah, it's probably a bit of both. For example, we know that muscle relaxants, for example, quinine sulfate, for example. Quinine, you cannot get a prescription from a doctor in the United States anymore for quinine, but quinine is a muscle relaxant and is one of the ingredients in tonic water. And so we've known for years that if you give somebody quinine or if they drink tonic water, like it seems harder or next to impossible to get them to get a muscle cramp. And so quinine impacts the muscle, obviously. And so there's probably something with cramping at the muscular level. But we also know that if I block a nerve from sending signals back to the brain, or if I block the nerve at the spinal cord level, I can still cramp people, even if I use like an electrical stimulator downstream from where I put the nerve block in. So if I remove the brain from the nervous system and I can induce a cramp still at the muscle, that tells me there's something at the muscle that is still being involved in order for somebody to cramp, right? Because if everything came from the brain, if it was a brain problem, when we put in a nerve block, then nobody should ever cramp. But people still cramp even with nerve blocks. And so there's something at the muscular level. There's also probably feedback happening in the brain, in the spinal cord. Like I said, this is a much more complex physiological problem than what we're making it out to be. And so it's probably a little bit of both, muscular level as well as nervous system level.
Okay. And you said tonic water.
Mm-hmm.
And, you know, those cans of tonic water, could we use that? Like Schweppes or whatever brand you have? Like a gin and tonic, right? If you mix...
Correct. So some people use tonic water, but the concentration of quinine in tonic water is very, very little. The dosages that we used to prescribe to people with like muscle cramps as a problem were at a higher dosage. So I don't know if anybody's ever done a tonic water study on muscle cramping, but I'm just making the point that the active ingredient that was a muscle relaxant is also commonly found in tonic water. So you can still buy tonic water today. You just can't buy quinine or get a prescription for quinine in the United States anyway from a physician due to cardiac problems. And so you don't want to cause heart problems to solve your muscle cramp problems.
Yeah. I was just going to say we can buy like 2 gallons of tonic water and reduce it down. But don't do that.
Not a great idea because you'll cause cardiac arrhythmia.
Yeah. Let's reverse back a bit. What motivated you in the early days to start studying cramping? What got you into the career path?
Yeah, so like a lot of folks maybe listening to this, I've studied with, or I've suffered from muscle cramping during exercise for a long period of time, especially in my adolescence, because I was a football player, soccer player. What we would call it here in the States, right? And so I got to college and I was interested in sports medicine and athletic training, and was in an exercise physiology class, and the professor made a comment that really got me thinking. And his comment was, you know, you athletic trainers in the room, I don't know why you think cramping is due to sodium loss, because when you exercise, you lose more water than salt in your sweat. So your blood actually becomes saltier, not less salty. And so I got to thinking about what he said. I'm like, my God, he's right. And so for 100+ years, though, we've been told like it's dehydration, it's sodium loss. but the fluid that's bathing the muscles that are cramping are becoming saltier when we sweat, right? And his point was 100% true. For most people, when we sweat, we lose much more water in our sweat than we do sodium. And so some of the studies that have been even funded by the sports drinks industry, for example, have shown that an athlete might lose 10 grams of sodium in a tennis match, for example. But in every single one of those athletes where you have more than 10 grams of salt loss, none of them cramped. And so to put that in perspective, the USDA recommends that healthy adults, take about 2 grams of sodium in their diet per day. These athletes were losing 5 times the recommended amount of sodium due to a tennis match, and not a single person cramped on those days. And so it's been a real interesting kind of phenomenon for me to study, because very few other conditions do we have people so profoundly convinced that it's one thing that causes it, only to have science and normal physiology say, well, wait a second, that doesn't make a whole lot of sense, because this is what's happening when we exercise. And so it was really kind of the interesting juxtaposition of, we're really confident that this is what we're supposed to do and what the cause is, and yet the science really doesn't support what we're doing in the field and the treatments for it. And so it really got me thinking kind of my past personal history of like, why did I cramp? Like, I had coaches tell me to eat more bananas or eat more kiwis. Like, potassium was my problem. And so, I mean, I ate so many bananas as a soccer player. Like, it was insane, right? Because I would still have cramps even after 2-a-day games or long weekend tournaments. And so that kind of personal history combined with the physiology that I was learning really got me kind of interested in this field, and kind of going down into the rabbit hole of studying, like, how can we better tease out what's going on with cramping?
When we cramp, some cramps are quite light, so to speak, right? You get a pull in your muscle, but it doesn't really stop you from doing anything. But some are severely painful. You're on the floor, you're trying to stretch it out. What makes those painful cramps so painful that your muscles seize up and they kind of deform quite a bit, right? And you can see it's like the spasm in your muscles.
This is an interesting observation. So there are definitely different severities of muscle cramping. And what's even more interesting is for those of us who have suffered from cramping, we know when we're about to cramp, right? Like, our brain will tell us, like, if you make this sprint, like when I was playing soccer, I knew, like, if I sprint and I catch this guy, I'm going to cramp in my calf. Like, you can sense that it's coming on, almost like this precognition of, I'm about to experience a cramp. And so people can stop it before it happens, right? And so they'll slow down or they'll rest a bit and try and make the cramp not appear. Other times, like, we get this full-on debilitating cramp where our athletic performance actually suffers. And so there is the wide range. It appears that the majority of cramps that occur to athletes fall into that mild to moderate category, where they're able to stop, rest, maybe do some stretching, or they hydrate a little bit, and then they're able to continue with their exercise. But there certainly do appear to be those situations where they are full-on debilitating. Like, I think back to the 2014 NBA Finals, where the Miami Heat and LeBron James were playing the San Antonio Spurs in San Antonio. And game 1 of that series, the air conditioning broke in the stadium. And so on-court temperature was over 90 degrees Fahrenheit. And so LeBron in the fourth quarter, I went back and looked it up. LeBron made about $6,600 per minute that he played that season. But in the fourth quarter, he was only able to play about 5 minutes of that game because he got full body or lower extremity cramping. In fact, there's a situation where he does a layup, lands from the layup, hops a bit, and then he can't move. And he has to actually be carried off of the court, and he can't even play the rest of the game. And so while the majority of them seem to be mild and moderate, they certainly, again, are cases where people can't resume work or they are physically unable to complete their athletic contest because of the game. Now, why are they so painful? Because within our muscles, we have nerve endings and pain nerve endings. And so when that muscle cramps and it shortens, it causes pressure and tension on those nerve endings, and that is what causes them to be so painful.
Okay. We'll talk a bit about climate, hot and cold a bit later. But you mentioned just now that your theory is that the causes of cramps is multifactorial, right? So if you kind of go through what could be some of the factors that actually do cause cramps. If you're using your sports watch or a generic formula to calculate your zone 2, there's a very good chance that you're not training in your true zone 2. And that's not because they are intentionally doing anything wrong. They simply don't know your individual physiology, so they estimate your training zones using population-based formulas. The problem is that if your zone 2 is estimated incorrectly, you can spend months or even years training in the wrong zone without ever realizing it. And that's a much bigger deal than most runners think. Zone 2 isn't an arbitrary heart rate. It's your own individual physiological tipping point where your body reaches its highest rate of fat oxidation before it starts relying heavily on carbohydrates. That point is different for every runner, and it also changes as you get fitter. So no generic formula can tell you exactly where it is. Which means if you're training from estimated zones derived from formulas, there's a good chance you're not training the energy system you think you are. Below your true zone 2, your body adapts to become better at burning fat, building the aerobic base that supports everything from endurance to speed. Drift just above it, and now you're training your body to rely more heavily on carbohydrates instead. That's not a bad thing, but it's a completely different adaptation and not the one you're aiming for. For years, I've used heart rate to measure training intensity, but heart rate is influenced by things like heat, hydration, caffeine, sleep, and fatigue, just to name a few. Then I thought lactate was the gold standard until I realized that lactate also changes depending on glycogen availability and your nutritional state, making it just as inconsistent as heart rate. That got me thinking that your breathing is one of the closest reflections of what's actually happening metabolically, because it's driven by your body's physiological response and not easily influenced by those external factors. As exercise intensity increases, your muscles gradually shift from burning more fat to burning more carbohydrates, which produces more carbon dioxide that your body has to remove by increasing your breathing. That change in ventilation happens at your own individual physiological thresholds and not at a generic percentage of your maximum heart rate. That's why learning about the VitaPro from Timeware was such a breakthrough for me. Instead of estimating training zones from generic formulas or indirect markers, it measures your breathing in real time to identify your own individual physiological thresholds that are not influenced by external factors. If you're serious about building your aerobic base, improving endurance, and making sure that every zone to run is actually doing what it's supposed to do, I think it's well worth looking into. Timeware is giving listeners of the Endurance Lab podcast $100 off their pro training membership when you use my link in the description with my code ELABTW26. And if you'd like to understand the science behind it all, check out my full conversation with Timeware founder Anar Larosen, also linked in the description below. If you kind of go through what could be some of the factors that actually do cause cramps.
Yeah, so some of them I think are kind of well studied. And so all of the listeners, please don't mishear me here. I'm not saying that dehydration does not play a role in cramping. I think it certainly does, but I don't think it's the role that most oftentimes is associated with cramping. Like most people, if they're in the dehydration camp, would say like, if you're dehydrated, you're going to get cramps, or dehydration from sweating causes an increase in the interstitial fluid space, and that increased mechanical pressure on the nerve endings causes the muscle cramp to occur. But the problem with that is people do lots of dehydrating activities all the time, but they don't experience muscle cramping, right? Speaking, drinking alcohol, going in saunas or hot tubs, walking around on a hot day is a dehydrating activity, but we oftentimes don't see people just grab their hamstrings while sitting in a hot tub and like scream out in pain. So it's the physical work that causes the cramp, not dehydration in itself. But what we do know from science is that when athletes are dehydrated, they fatigue much more quickly. And so could dehydration play a role in causing premature fatigue or changing excitability from a nervous standpoint? That I do believe could be a factor. So I'm not saying dehydration doesn't play a role. I'm just saying it's not the singular cause. So some of the factors that are like in my multifactorial theory, dehydration, yes. Fatigue and anything that can invoke early onset fatigue, like maybe a bad night's sleep, things like bad nutrition, right? If you don't have enough carbohydrates or if you don't replace your muscle glycogen, maybe that can play a role. Anxiety and the psychological effect of anxiety and stress and pain oftentimes I think is an ignored area of science. Like we forget that what we think and our psychology impacts our physiology a lot of times. We want to treat these medical conditions like they're purely physiological sometimes. And so I think stress, anxiety, pain, your perception of effort or how you're doing, I think, can play a role in your muscle cramping risk. And so those types of things all combined together, I think at just the right time can increase and combine to reach your cramp threshold. So I always propose it to people like this, like pretend you're a high jumper, right? That bar represents where your cramp threshold is. And then depending on, again, how you lived your life in the last 48 to 24 hours, whatever, modifies that bar up and down for how likely you are to cramp during activity. So if you have a bad diet, your bar for cramping gets lowered. So now all of a sudden becomes easier for you to cramp. And so if you're dehydrated or if you're not replacing your fluids as well as you should, you start here, but now you're hypohydrated. You get a little bit closer to the bar, but you don't cramp. Because again, just dehydration by itself doesn't appear to cause cramping. But then you combine that with a bad night's sleep, and now it's the Super Bowl or your World Cup final, and now your anxiety and stress and your psychology is higher and your nervous system is more excitable. Now you hit your threshold and boom, now you cramp. But you take away one or two of those things, and all of a sudden, even with one of the factors still present, you don't cramp that day. And so again, I think that better explains why some people cramp on some days and not others, why some people don't have a problem drinking some of these concoctions that we hear in the market, and some people have no success with them. It's because, again, everybody is a unique human individual and everybody's recipe is different.
And we're all at different levels on different days as well, right? So,
right. And then modifying all of that is just your own genetic predisposition toward cramping. So it seems that one of the most consistent identifying factors of whether you're going to cramp or not is a previous history of cramping. And so if you have a personal history of cramping or a familial history of cramping, chances are then you are going to be a cramper. And so I did some research a few years ago where we took hydrated people, no exercise whatsoever, just put them on a table. These were people with a history of cramping, and we simply asked them to cramp themselves. And so a lot of people like me, for example, like if you move a muscle in a certain way, if you hold it as a maximum contraction for a little bit, oftentimes can induce a voluntary cramp in themselves. It's not very fun, but people can do it. And so we had people come in, again, no exercise, no electrolyte loss, no dehydration, no fatigue, just sit on a table, cramp yourself. And then after they cramp themselves, I hooked them up to my electrical stimulator and I tried to cramp the same muscle 30 minutes and 60 minutes after they experienced that voluntary cramp. And it was easier for me to cramp them a second time after they had experienced their voluntary induced cramp. And so for 30 and even 60 minutes after that voluntary cramp, your susceptibility to cramping increases after the first cramp, which is something I think that a lot of athletes experience, right? Like if they get a cramp in the second quarter of a football game, they get a cramp in the third quarter. And then they get a cramp in the fourth quarter. Then they get a cramp on the bus, right? And so there's a period of prolonged susceptibility to muscle cramping. And what my work showed was cramping in and of itself, irrespective of dehydration, electrolyte loss, and fatigue, seems to alter people's cramp risk. And so what I always tell people is after you cramp, understand that your likelihood of cramping is going to happen again for several hours. So you can't just stop the cramp that you just had and then think, well, now I'm going to be fine. I can finish my marathon or I can finish my swim, because your likelihood that you're going to get a second cramp, third cramp, etc., stays for several hours post-exercise.
So you kind of have cramping days and non-cramping days.
Right. And so the interesting bit is trying to figure out, like, why do you even have a non-cramping day? And so that's where the holy grail question, which I'm sure we'll talk about, is how do you prevent cramps?
Yeah, right? We'll get to that for sure. Yeah.
Stay tuned, listeners.
Yeah, exactly. When you talked about the multifactorial factors, you didn't mention anything about electrolytes. You talked about hydration, fatigue, and a few other stuff. Does electrolytes actually play a role? And I know, based on what you say so far, it may not be a major role, but is it a contributing factor?
So this is a great question. Again, for 150 years, we've been told like it's dehydration and electrolyte loss. And a lot of the early pioneers in this area would point to like case study research on miners or people that were working in cane cutting or people on ships. Like they're in the bowels of the ship, like it's very hot. They're sweating profusely. They're losing a lot of sodium in their sweat. They're not replacing it. And so a lot of this early work showed that like, oh, if we give like the Hoover Dam workers a saline drink, they won't cramp anymore, or they have reduced cramping. And so they said, well, the cramps must be due to sodium loss. But the problem with this is, yes, electrolytes are very, very important for muscle contraction. Electrolytes like calcium and magnesium, sodium, potassium are vital to have normal muscle contraction and normal neural signaling. But the problem is when we look at data on people who actually cramp during, let's say, a marathon and people who don't. So we're not talking about people with a history of and no history of. We're talking about we actually observe the real phenomenon we're trying to study here. When we look at their blood and we look at their sodium loss and the amount of electrolytes that are in their sweat, there's oftentimes no differences between our two groups of people. And in fact, if sodium loss cause cramping, then we should see cramping all the time in people with hyponatremia. Hyponatremia is a low blood sodium concentration that becomes oftentimes deadly. But what we see is we don't see that happening in the hyponatremic athlete. And so even the people that are the worst sodium losers don't experience muscle cramping. And so when we take a look at the two different groups, they're oftentimes not different. Now, a lot of the other electrolytes like calcium, magnesium, we don't tend to lose a lot of those in our sweat. And so primarily the research has surrounded things like potassium and sodium, with sodium being by far the most studied electrolyte in humans when it pertains to muscle cramping. But my group, we did the largest prospective study in Division I collegiate athletes that's ever been published a few years ago. And we looked at 11 different sports, male and female. And we compared sodium loss, potassium loss, sweat loss, potassium content, sodium content, all the major electrolytes in your sweat. And we compared them to athletes with and without a history of cramping during an exercise session. And in 10 out of the 11 sports, if you were to hand me a sweat sample and ask me, Kevin, can you tell me if this is coming from a cramper or a non-cramper? I can't tell the difference from their sweat. Now, the one sport where we actually showed that electrolyte loss, specifically sodium loss, was correlated with history of cramping was in the sport of American football. And so there might be something very special about American football. Like maybe the athletes are very, very large. You know, they're wearing heavy protective equipment. Their season is in the hottest part of the year, especially in the Northern Hemisphere. In like the United States, for example, training camp usually starts in July. The season goes from August until December. And so typically we see a lot of people with cramp issues in August. And so a lot of the, like I said, earlier work would say, well, look, we have all these American football players. They're cramping in August, like in the first week of practices. Well, is the only thing that's happening to a person when they exercise in the first week of practice sweating and electrolyte loss? Like, have these guys been training as hard as they've been asked to compete when they come back to a coach supervised practice? I kind of doubt it. Right. And
so the level of fatigue tolerance might have been reduced in that first week of August, right?
Exactly. And so after that first week, what we notice is like in August, cramping almost disappears. It's almost always in the first 2 weeks of conditioning and when practices resume. And so again, I tend to believe it's a multifactorial issue. I think you have people who are not heat acclimated yet. They're not used to being in hot conditions, wearing pads, doing sprints and high conditioning activities daily, right? Where they're asking their body to replenish their nutrient sources, their glycogen very quickly because, you know, they have a second practice coming up the next day, or, you know, you have this period of very intense physical activity in a short amount of time. And so a lot of times I believe that cramping is the result of doing exercise that the person has not prepared their body for. right? And so a lot of times we see cramping during competitions, but not necessarily during practices. Well, why is it during competition and not practice? Well, it might be because during competition, you're trying harder. You're going at a higher intensity than what you practice, or maybe you're not using the equipment during practice, but you are during the games. And so again, it's a multifactorial problem, but we look at these situations and we say, okay, well, there's more than just dehydration or electrolyte loss that's happening to the body with exercise. There's fatigue, there's dehydration, there's electrolyte loss, there's lactate buildup. There's a whole bunch of things happening to the body. And dehydration and electrolyte loss is not a local problem, right? If cramping during exercise was due to just dehydration or electrolyte loss, then we should experience random muscle cramps all over the body.
All over the body,
right? Yeah, I should get shoulder cramp.
Or face cramp.
It always seems to be the muscle that is working, or the muscle that is being asked to do a task that it has not been prepared to do. And so the other thing I would point people to is, what is the cure, or what is the treatment for cramping? If an athlete goes down with a calf cramp on the soccer pitch, what do you do for them, right? We almost always stretch them, right? You perform gentle static stretching of the calf. So you take the foot and you dorsiflex it, you bring the toes toward the chest. That puts the muscle on stretch, and it almost immediately relieves the cramp. And so what I would ask you is, how much fluid is added to the body by stretching?
Nothing.
None. How many electrolytes are added to the body by stretching?
Nothing.
It's
You're probably still losing it as you're sweating.
Yeah, well, if cramping was due to dehydration or electrolyte loss, why does stretching work to relieve the cramps then?
Yeah.
Right? If the cause of exertional heat stroke and death from exertional heat stroke is having a high body temperature, and I told you the treatment for that is acupuncture, you would laugh me out of the scientific symposium, right? But that's what we're saying with muscle cramps. Well, the cause is dehydration, but the treatment is not hydration? What? It doesn't make any sense. The first thing I do for an athlete is not throw them a sports drink. The first thing I do for them is stretching. Well, if dehydration and electrolyte loss is the problem, then the cure should be hydration and electrolyte replenishment. But that's not the treatment for cramping. So again, it's more complex than what people think. And I think when you look at all of this evidence combined, there's much more scientific support that this is a multifactorial problem than a singular cause like electrolyte loss or dehydration.
Okay. But I guess we're also not saying to athletes that they should not hydrate themselves, right? That they should still be hydrating themselves, and they should still be consuming some electrolytes so they don't get into hyponatremia.
Oh, absolutely.
Which is saying that is not the cause.
Right. So that's a completely different podcast altogether, right? The importance of hydration.
Correct.
And please hear me very carefully too. I'm not advocating against drinking sports drinks. Sports drinks definitely have a place, when it comes to rehydration, for example. If I offer you a sports drink versus regular water, I know you will retain more water with that sports drink because there's good physiology and good research behind the effectiveness of glucose and sodium combined with water in a rehydration beverage for retaining water. In fact, if I just give you pure water after you've done a week worth of exercise in the heat, right, you will not be able to fully rehydrate. The body needs electrolytes, and specifically sodium and potassium, to fully rehydrate inside the cell and outside the cell. So there's good research for that. Plus, we know that people prefer the taste of sports drinks, right? Because there's sugar in it.
Yeah.
And so even though, if you have a moderate intensity exercise session that's 60 minutes long, there's almost no benefit to drinking a sports drink versus drinking water, right? But I know from a rehydration standpoint, people prefer the taste of the sports drink, so they'll drink more of it.
Yeah.
And so the issue, though, is sports drinks oftentimes have as much sugar in them as soda.
Yeah.
And so from a, obesity standpoint, people used to think sports drinks are a healthy alternative to soda. So we'll put them in every middle school and high school because it's a healthier option. But then when you look at the nutrition label, it's the same amount of sugar as the Pepsi.
Exactly.
Right. And so absolutely, hydration is important. We know from research that about 3 in 4 athletes will show up to an athletic contest or a exercise session already in a significantly dehydrated state. We know that research is clear. And again, we know that people fatigue much sooner, exercise is much harder, if they start that exercise session already dehydrated.
Yeah.
And so hydration is very important, especially for maintaining our blood pressure and blood volume. Electrolytes are important as well. But when it comes to does that cause cramping, which is the topic of our current conversation, the scientific evidence right now would suggest that it does not seem to be related to how much sodium or potassium or other electrolytes are lost during a typical exercise session. Plus, from an American standpoint, in American diet, our diets are horrible. I mean, the average consumer in America buys so much processed food, and all of that processed food usually has a ton of sodium in it. And so sodium replacement, like from a middle school and high school standpoint, is almost never a concern in America, right? Our kids, even though they might go to a 2-hour football practice, while they're coming back to the cafeteria and they're eating Cheetos, Doritos, hamburgers, pizza, all of these high sodium foods. And so from a replacement standpoint, getting enough sodium is almost never a problem in the typical American diet. But where people, I think, have fallen into a little bit of a trap is a lot of the marketing for a lot of these sports drinks says like, well, this sports drink contains electrolytes, but there's more water in those sports drinks than there is sodium or other electrolytes. And so the amount of sports drink you would have to consume to replace your sodium and other electrolytes is dangerous, right? And so those drinks are hypotonic, meaning that there is more water in them than there is salt. And so any sports drink in America or otherwise does not contain enough electrolytes to actually replace the electrolytes you lose during a typical exercise session. In fact, if you were to take a look at the amount of sodium, like we talked about in those tennis players earlier, that lost 10 grams of sodium in a 4-hour tennis match, the amount of sports drink that I would have to drink to replace that electrolyte loss is something equivalent to like 30 liters of sports drink. It's just an absurd amount of electrolytes. And so if you don't believe me, do the math. It's really easy. You just take how much sodium you lost, you look at the nutrition label on the sports drink, and then you divide the two, right? And then that's how many of those bottles that you have to drink to replace it. And it becomes dangerous. And I gave a talk very similar to this a few years ago at a national convention. And I made that comment to people. I'm like, if you give this amount of sports drink to an athlete, you are going to kill them. And in my post-convention speaker feedback, I got comments like, Kevin's being hyperbolic and dramatic. Like, you would never kill an athlete if you gave them sports drinks. And then sure enough, 2 years later, in 2014, we lost 2 healthy American high school athletes. Both athletes were trying to prevent muscle cramping, and they drank so much Gatorade or sports drink and water that they gave themselves hyponatremia, and they unfortunately passed away. So Walker Wilbanks and Zyrese Oliver died within 2 weeks of each other in 2014, both in August, and both were trying to prevent cramping. And you can kind of understand their logic because we've been told this for 150 years, right? Like dehydration causes cramping. Well, if I'm trying to prevent cramping, and I've been told that by doctors and other medical professionals for years, well, then I know I got to drink. I got to drink. And so I get a cramp during my practice. So I think, well, I must be dehydrated. And so I drink more sports drink. And then I get another cramp during football practice. And so I think, well, I must still be dehydrated. And so I drink even more. And so in Zyrese Oliver's case, for example, we think he consumed about 4 gallons of combined sports drink and water. He was vomiting clear fluids in his coach's office before they finally decided to call 911. And he passed away in the hospital a few hours later due to hyponatremia. Again, there's more water in sports drinks than there is electrolytes. And so when it comes to rehydration, you have to educate your athletes and educate yourself on what is a safe rehydration strategy. And so this is why I always recommend to people, like, if you don't know your own sweat rate, and by the way, knowing your own sweat rate is very, very simple. Like if you go for a 30-minute run or an hour run, the longer the exercise session, the better, because the first 30 minutes or first 10 minutes of an exercise session, your body temperature hasn't increased yet really. And so you don't really start sweating. So the longer you can do it, I usually recommend like an hour. So if you look at your body weight before you exercise and then after you exercise, assuming you don't drink anything and you don't go to the bathroom during that 1 hour exercise session, any change in mass is sweat. So if you start exercise at 100 kilos and you end at 99 kilos, we know that your sweat rate is 1 liter per hour because 1 liter of sweat weighs about 1 kilogram. Okay, so if you know your sweat rate and you know it's 1 liter an hour, then you know to safely rehydrate, you got to drink a little bit more than your sweat rate. Because as you start to rehydrate, you have the urge to pee. Well, peeing is dehydration, right? And so every fluid national organization would tell you got to drink a little bit more than what you lost to accompany the peeing that you're going to experience as you try to rehydrate. And so typically we would say, okay, if your sweat rate is 1 liter an hour, you got to drink about 1.2 liters to fully rehydrate. And so having safe rehydration guidelines is paramount, especially for young athletes and people so that they don't end up like Walker Wilbanks or Tyrese Oliver.
Yeah. Would salt tablets help in that regard?
So salt tablets are very popular back in the, I would say, 1970s. It seems like extra sodium supplementation before races does not appear to predict or stop muscle cramping during exercise. And so loading up with high sodium solutions beforehand doesn't seem to be helpful. No.
Okay. Between exercise-associated muscle cramps and nocturnal cramps, is there a difference? Well, the reason why I'm asking this is I have this impression that some of these nocturnal cramps could be caused by the exercise of the day, and just when you get to bed and you relax, for some reason you get a cramp. It happens to me. I cramp. I'm a cramper, right? I can cramp in every situation. So how related is that?
Yeah. So again, when we started this whole thing, really important to define which type of cramping you're talking about, because to call one cramp the same as another cramp, I think we're getting into some territory here where we're not quite clear on. But nocturnal cramping is a really great case of this probably is a phenomenon that has to be neurological, right? Because when you're asleep, your body is like essentially knocked out. You're unconscious, right? But for you to have sustained muscle contraction activity while your brain is essentially off, right, to your muscles, tells me that this must be neurological in nature. It can't be metabolic, or it can't be dehydration or electrolyte loss because you're sleeping. Okay, so something is happening within the nervous system to those muscles while you're sleeping that's causing those muscles to cramp. But I think you hit the nail on the head there a lot of times, because again, going back to our earlier conversation, a lot of what we do during the day builds up over the course of the day. And so if you don't fully get yourself back to a baseline by the time you go to bed, what you experience as nocturnal cramping might just be leftover stimuli from the day, and now your body's just finally catching up and you get the cramp at night.
Okay. And sometimes after a hard workout and you're sitting on the sofa chilling out and you still get a cramp, I'm guessing that could also be a aftermath of the work. It could have been an aftermath of the workout combined with some of those factors, right?
Right. And so again, your predisposition to cramping after exercise stays for a prolonged period of time, especially if you get a cramp during that exercise bout. Like I said, with our voluntary cramp induction experiment, like we were able to more easily cramp people up to 60 minutes after their first cramp. And again, just tells me that the cramp in and of itself changes the neurological system and the physiology of that muscle, and your risk goes up for a period of time afterwards.
Okay. Let's bust a couple of quick bits with some rapid fire questions.
Sure.
First one, do bananas prevent cramps? I know you took a lot of bananas in your younger days, but do they actually help?
So we did a study where we gave people 0, 1.5, or 3 servings of bananas post-exercise in a hot room. And we dehydrated them to, I believe, something like 2 to 3% of their body mass loss. And then we made them eat 3 different trials of banana amounts. And so, like I said, 0, 1.5, and 2 servings, which from a practical standpoint is the equivalent of 1.5 bananas or 3 bananas. And so we asked people to eat them in 2 minutes or less. And then we took blood samples from them up to an hour post ingestion of the bananas. And we wanted to know, how fast can we change potassium in the bloodstream if you eat bananas? And what we found was, with the 3 servings of banana group, it took a minimum of 30 minutes to see an appreciable increase in your blood potassium concentration. When you ate 1 serving of bananas, so that'd be 1.5 bananas practically, it took 60 minutes to see an appreciable increase in your blood potassium concentration. And so if you cramp and I hand you a banana, it's not going to be a miracle cure for your cramp, because anything that we take in orally, right, has to go down the esophagus into our stomach, be broken down by our stomach, absorbed by our small intestines, circulated through the bloodstream to our cramping muscle. And all of that just takes too long to help you in the moment. Now, what we also found in that study, though, was glucose changes in the blood much faster than potassium concentration does. So if your cramp recipe includes fatigue or loss of energy, for example, then giving you a banana might help by restoring your glucose. And so it takes about 15 minutes to see an appreciable change in your blood glucose. And so from a prevention standpoint, we don't know the answers to that question yet. But the study that I did showed that it takes a minimum of 15 minutes to see a change in blood glucose. The potassium barely changes within a short amount of time. Like I said, it takes about 30 to 60 minutes. So that's probably not going to help you. But from a glucose standpoint, if your recipe includes fatigue, that might help you, but just recognize it's going to take about 15 minutes. So in the United States, for example, your typical American football game has a halftime that's around 10 to 15 minutes long. So if you were to give an athlete a banana and a half at halftime, by the end of that halftime, you can expect that their glucose will at least be higher, and then maybe that might help you. But from an electrolyte standpoint, from a potassium standpoint, bananas, probably not the solution.
Okay. What about pickle juice?
Now, pickle juice is an interesting phenomenon in and of itself, and probably worthy of another podcast. I have done more pickle juice research than anybody else on the planet. And so when I was doing my PhD, our American football team was doing back-to-back shots of like pickle juice, and they would drink water, and they would do this before games, and if they experienced the sensation that they were going to cramp in our athletes. And so I was sitting in a class one time, and we were talking about this phenomenon, and somebody just raised the question like, well, how fast can you change electrolytes in the bloodstream if you drink pickle juice? And of course, nobody had looked at that question. So we did that question. So we gave people a small volume of pickle juice, the equivalent of 2 shots, like to put it into the college vernacular. So people are drinking a small volume, about 80 milliliters, not a whole lot. It's usually like 2 or 3 swallows. And that volume was said to stop and even prevent cramping in some athletes. And so what we showed in multiple studies, we did it in hydrated people, dehydrated people, exercise, no exercise. We did multiple shots of pickle juice during exercise. We've done it preventatively. What we showed was it doesn't change the bloodstream, right? Like 70 to 80 milliliters of pickle juice does not change blood sodium, potassium, calcium, magnesium, osmolality, plasma volume. It doesn't change any major blood characteristics. But what does seem to be an interesting phenomenon is it does seem to stop muscle cramping faster than deionized water or drinking nothing at all. And so I did a study, I think it was back in 2009. It got published in 2010 in Medicine and Science and Sports and Exercise, where we put people through exercise and we cramped a rested, unexercised muscle. And so this was the very first study that I'm aware of that tried to tease out the dehydration from fatigue phenomenon that we see. A lot of the research up until my study was all in athletes. And again, there's more than one thing that happens to a person when they exercise. It's not like they're either dehydrated or they're not when they exercise, right? There's lots of conflicting things that are happening. And so what my group did is we dehydrated people with semi-recumbent cycling, but we left one leg off the bike. So their dominant leg was rested, unexercised the entire time, but they did one-legged biking until they lost 3% of their body weight. And then we took their blood samples. We knew how much sodium that they lost. We knew how much plasma volume they lost. And then I induced the cramp in the rested, unexercised muscle before and after the dehydration. What we found was people were just as easily crampable when they were dehydrated as when they were hydrated. And so when you tease out dehydration from fatigue, it doesn't seem to impact cramp risk, which again is why I tend to believe cramping is not as much related to dehydration and electrolyte loss. But then the second part of that experiment was we then induced a cramp in a muscle, and then we gave people either water or pickle juice to drink. Again, small volume, about 80 milliliters. And what we found was the pickle juice stopped how long the cramps lasted by about 30 to 40% faster than water or nothing at all. And so the average amount of time people cramped was about 90 seconds, when they drank the pickle juice trial. Now, we took blood samples at 1 minute post-ingestion and 5 minutes post-ingestion. So we knew sodium wasn't changing. None of the other electrolytes were changing, but the cramps didn't last as long. And so we said the effect had to be neurological in nature. And so what I think is happening is when you drink like a solution like pickle juice, I believe it's the vinegar or the acetic acid that's in that solution that is triggering a reflex in the mouth that then causes the muscle cramping to stop. And so I equate it to like when you like slam your hand in a car door, for example, and you hurt your fingers, you grab somewhere else on your body and squeeze, and that helps with some of the pain in your hand, right? The brain can only handle so much stimulation. And so what I think that pickle juice is doing is it's causing an interruption of the neurological firing from your brain to the cramping muscle long enough to actually stop that muscle from cramping. We certainly know it's not electrolytes. Like I said, we've done also studies where we've given people small volumes of pickle juice and measured how fast it leaves the stomach. And we know that for about 20 minutes, the pickle juice is staying in the stomach. It hasn't even left the stomach yet, so it can't have been absorbed into the bloodstream. Plus, we have all this data showing that the bloodstream stays completely the same with small volumes of pickle juice. But we have this weird phenomenon where it doesn't seem to be changing the blood, but it does shorten cramp duration. So it's probably a neurological effect. Now, I'm not saying a placebo effect. It's probably an oral reflex.
Some receptors we also see in the mouth to the brain that causes it, right?
Right, because we tried to blind people as best we could. We put nose plugs on. Like, I didn't know what solutions that they were drinking on the day. The subjects didn't know what they were doing or what they were drinking. But obviously, as soon as pickle juice hits your mouth, you know you're drinking something. But we never told people like what they could expect. And so pickle juice could have made their cramps worse. We don't know, right? And so we tried to blind people as best we could so the results could be as fair as possible. So something seems to be going on with pickle juice. And if it is the acetic acid, then we should have pretty decent results with other types of vinegar solutions like apple cider vinegar. Because a lot of people have reached out to me and they said, well, what about like bread and butter pickles or, you know, like vinaigrettes or these things that, because people just don't like dill or the taste of pickles. And so we've had anecdotally success with apple cider vinegar as well. I did a study where we gave people pure white vinegar to drink. And then I looked to see, could I cramp them up to 60 minutes after they drank a double shot of white vinegar? I don't recommend that. When I tried it, my throat burned for about a day and a half. So I recommend something more gentle on your gastrointestinal system, kind of like apple cider vinegar. If you're going to try this, I always recommend, talk to your doctor first, right? You don't want to have somebody with high blood pressure drinking a very salty solution like pickle juice to try and solve their cramping. But apple cider vinegar does seem to help people as well. But until we do more blinded trials, it's still something that we're trying to figure out.
Okay. When I ran my first 100K ultra marathon, I didn't have any salt tablets with me, and at the aid stations, I was starting to cramp, and on the aid stations, they had pickles, and I started taking my cup and taking the pickle juice, just the water. It helped. I didn't really develop a cramp through the whole 20 hours that I was running it. But yeah, I mean, it's anecdotal, so that's why I'm asking it. The other one I want to ask about is coconut water.
Coconut water, we, to my knowledge, not done any studies on coconut water and cramping or prevention of cramps. I can't even comment on that one.
Okay. Yeah, you were going to say something. Sorry, I interrupted you just now.
I was just going to say, so the study we did with the pure white vinegar, we also did pickle juice. And in the pure white vinegar trial, I could not cramp anybody like 30 minutes or 60 minutes after they drank the white vinegar. But in the pickle juice trial, I still could cramp people. So again, it tends me to believe that it's the acetic acid. Like when you give a powerful dose of acetic acid, because in pickle juice, for example, the acetic acid is not as high as when you're drinking just pure vinegar. But it's harder on the system. Like I said, my throat got scratchy, and that's why I would recommend a more gentle type of vinegar if you're going to try that. But yeah, pickle juice does seem to help people. Like it helps me. I know I've had muscle cramp situations, and I've come into my house and just straight from the pickle jar drank pickle juice. There's even some companies out there that make a pickle juice brine type sports drink and claim that it helps with cramping. In fact, this past World Cup, for example, when the United States was playing, one of the referees went down with muscle cramps, and somebody ran out to him and handed him this bottle, which I believe was one of those pickle juice products for cramping. And I know the guy drinks it, and he's also being stretched out by, I think, our striker, and then is able to finish the match and referee the rest of the match. So there does seem to be something with pickle juice. We're just trying to figure out the mechanism and how it works. But there have been some studies that have come out where they've done like mouth swishing with just pickle juice, and then people spit it out. So if there is an oral pharyngeal reflex, just swishing around your mouth should help. That study showed that mouth swishing helped people with cramping a little bit. It wasn't like statistically different than like the ingestible pickle juice or their water trial, but it did decrease the duration and made it harder for people to cramp. But what those scientists didn't do in the study was make people exercise. And so again, if your multifactorial theory is correct, right? If you don't prime the muscle to look like an exercise person would look before they cramp, then the solutions that you're trying to use for treatments might not have an effect because you haven't essentially primed the system to give the phenomenon that you're trying to study. And so, like I said, we're still trying to figure this out and what the mechanism might be when it comes to pickle juice.
Okay, but white vinegar does work to prevent white vinegar, cramps. Or you couldn't cramp someone with white vinegar.
Yeah, I couldn't cramp people. Again, I would not recommend pure white vinegar because it's just really tough on your esophagus because of the high acidity.
I guess you can dilute it with water or with like a sugar syrup, like in a sports drink, and you add some vinegar. That's gonna tone it down a bit.
Right. So if you were to try like a raspberry vinaigrette, for example, the tricky part is like all these solutions out there have differing concentrations of acetic acid in them. And so there was a study that was published where they looked at like 8 different solutions of like pickle juice. And so when I was a student, for example, I reached out to Vlasic and just asked them like, what is the concentration of vinegar or acetic acid in your brine? And they told me like after several attempts, because they wouldn't answer my question, I think they were trying to think like I was a competitor, like trying to figure out their recipe. But after assuring them, like, I'm not going to try and make a pickle recipe, they told me it's somewhere between 2 and 40%. I'm like, all right, well,
what?
2 and 40%.
Between 2 and 40%. That's a huge range. Yeah. Okay. Yeah.
And so it's a huge range. So some scientists published a study a few years ago where they actually measured the acetic acid concentration in different types of pickles and different types of sports drinks that are supposed to help with this, pickle brine effect. And they found that, these solutions vary in concentration. So what you're saying is absolutely correct. Like if you were to try and make this at home and you dilute it, then you might actually change the efficacy of it because you might dilute it so much that you lower the concentration so it doesn't work. Again, we're still trying to figure out what the magic is in pickle juice, but I would recommend, trying to figure out what is your recipe for why you cramp before you start trying these, magic solutions or powders or lotions or those types of things.
So heat and cold, just now you talked about heat causing LeBron James to cramp very badly during one of those matches. So between an environment that's hot and an environment that's cold, I guess, is it fair to say that a hot environment someone is more susceptible to cramp in a hot environment than in a cold environment?
So this one is tricky. And so I'm not saying that the heat caused LeBron to cramp. I'm just saying that in that particular game, the air conditioner was broken, so it was hotter than normal. So again, if cramping is due to exercise that the body has not prepared for, or if that's a major factor, which I tend to believe that it is, if LeBron is used to playing in air-conditioned stadiums, going at a hard level, high intensity, and he doesn't cramp, but then on the hotter conditions, he does cramp, then that might be not necessarily the heat caused him to cramp, but his body hadn't been prepared to do that. So there's a principle in exercise science called the SAID principle. And SAID is an acronym. It stands for Specific Adaptation to Imposed Demands. And so the body adapts to the stressors that you place on it. So if you begin a strength training regimen tomorrow, for example, but you do bicep curls and you start with 10 kilograms of weight, but you never increase the weight, your body gets really good at lifting 10 kilograms. but that's all it does. You'll plateau eventually. Like your body just gets used to that. That's why you got to do progressive overload if you want to keep getting stronger. If you want your muscles to increase in size, you have to keep stressing the body. Well, in that particular day, what I think is LeBron's body was not used to those conditions, so it had to work harder for the same level of his intensity, and that's probably why he cramped. Now, what's interesting about exercise cramping is they've been delegated to exercise heat illness kind of category, with things like heat exhaustion, heat syncope. In fact, we still have the terminology these days of heat cramp. And I always tell my students, like, how many of you have had a heat cramp before? And like almost every hand goes up, and I'm like, no, nobody has. And like, heat cramp is a bad terminology because we know that cramping is not related to your body temperature. It's not related to your rectal temperature, your internal body temperature at all, right? People with exertional heat stroke don't first get muscle cramps and then get heat exhaustion and then get heat stroke. They just get heat stroke, right? And so muscle cramping is not related to your internal body temperature. It doesn't seem to be related to your muscle temperature. It doesn't seem to be related to the environmental temperature. People cramp in air-conditioned facilities. They cramp in hot facilities. They cramp in pools where the pools are quite cold, right? And so the ambient temperature, the muscles temperature, the body's temperature, the skin's temperature doesn't seem to play a role in what causes cramping. And so to keep calling them heat cramps is bad terminology. And then you add on top of that, the treatment is not an ice pack, right?
Yeah,
so if cramping was due to the heat, then the treatment is cooling. But again, the treatment for an active cramp is stretching. Well, stretching doesn't impact body temperature or muscle temperature whatsoever. And so all of that evidence combined, we need to get rid of the term heat cramp forever, because it gives people the false impression of what the cause is, and then therefore what the treatment is. And as we know, that those aren't factors that play a role. So heat might play a role in the fact, again, could be a external factor, one of those things that might be part of your recipe, but it's probably related to making the body work harder than it typically is used to.
So once you get that adaptation, then it might not become a factor anymore. So if you're heat adapted, you might not be cramping in the heat, right?
Right. But there is data out there that shows people get more muscle cramps during the month of August, for example. But then in September, October, November, they're like cramps go away to nothing. But again, is that because you're starting exercise and your body's not used to the exercise? Or is it because of the hot environmental conditions? I think it's probably a bit of both. And so the fact that the cramps seem to go away completely in like September or October tells me it's probably more conditioning. Because by then your body is adapted to the equipment and the exercise intensity and those types of things. So again, I think it's related but not causal.
Okay. Let's get to the most practical part about this, of this conversation, and that's what someone can do to prevent cramps, considering that there's so many factors that can cause cramps. So is there a protocol that someone can adopt daily that helps them mitigate the risk of cramping?
Sure. So the cramp prevention answer is like the holy grail in this research area. And so again, people want to believe something that is more simple, right? Just tell me what to do. Just drink more pickle juice. Okay, I'm going to do that. And I'm sure some of your listeners are just thinking like, okay, I'm just going to start drinking pickle juice. But the problem is, again, the body adapts to what you do to it. And so this is something that, again, we need to study more, because one thing we know with like electrical stimulation in rehab, for example, is eventually the body adapts to your current stimuli intensity. And so what happens is, to like decrease pain, for example, we have to increase the electrical stimulation. And so again, the body adapts. And so if you start drinking pickle juice, eventually your body's going to adapt to that stimulus. So then you might need more pickle juice or more acetic acid. And so we would call that habituation. So the answer to the question, what prevents cramping, I think is harder than what most people like. And this is where athletic trainers and the people when I give these talks all around the world really hate about me, as I tell them, muscle cramping is harder than just drink this, or just, rub this potion on your legs, or just do this one thing and your cramps will go away. If we, again, start with the premise that this is a multiple complex phenomenon, and there are multiple roads that lead to Rome, there are multiple ways that you might cramp. the answer to that question of how to prevent cramping then becomes, we need to know what your recipe is for cramping, right? Because if I recommend something that isn't one of your factors, you're going to say, well, that didn't work, right? Well, and of course it wouldn't work because it wasn't in your recipe. And so the first step is to acknowledge that cramping is not as simple as we want to believe, right? And so step one, we have to rule out any general medical conditions in your medical history. So I always tell people, like, first, rule out like diabetes, hypothyroidism. Make sure that the only thing wrong with you is that you get muscle cramps during exercise, right? If you have ALS, for example, or if you have Machado Joseph's, or if you have other neurological diseases or disorders, then that your cramping might be related to that underlying general medical disorder. So we got to figure out that first, right? The problem then is not the cramping. The problem is your general medical history problem, right? So solve that first. But if you're healthy and the only thing that is wrong with you is you get cramps during exercise, then we move on to the figuring out what is your recipe for cramping. And so to do that, in the article where I proposed the multifactorial theory, I put a table together of like 16 questions that you can ask yourself or your athlete to try and figure out what is your recipe for cramping. And so what I always recommend people do is essentially keep like a cramp journal. And so when you get a cramp during exercise, you answer all of these questions. And the questions are things like, what was your nutrition like the last 24 to 48 hours? Like, did you focus on carbohydrate replacement? What was your exercise session like? Was it harder than normal? Were the environmental conditions hotter, colder, more humid than normal? What was the duration of your exercise? How long was your run? How was your sleep the night before? So you go through all of these questions and you try and figure out that, okay, today when I cramped and I answer these questions, yep, I had a bad night's sleep. I was wearing brand new shoes, and I ran the same amount of distance as I always do. And so maybe what I need to do is focus on my sleep then. Because when I have a good night's sleep and I do the same run in the same shoes, in the same environmental conditions, I don't cramp. And so then I would say, okay, your recipe, sleep is an important factor for you and your cramp development. So we need to focus on sleep strategies for you. But for other people, if they get a good night's sleep, they have good nutrition, they're good hydration, and they still cramp, all right, well, what are we missing? And that's where this broad spectrum of questioning comes in to figure out what is your cause. And so when you get another cramp, you go through, do the same answers to the questions, and then you start looking for patterns in the data. And you say, well, every single time I cramp, it was bad night's sleep, and I didn't get enough carbohydrates in my diet the 24 hours before or the 24 hours after my exercise session. And then after you identify those patterns, that becomes your prevention strategy. And so essentially what we need to do is we treat muscle cramping like any other injury in the body, right? I tell my students, like, if you had an athlete sprain their ankle, what are you going to do for them? And they say, well, in the evaluation, I would ask them questions about, like, have you ever sprained your ankle before? How much does it hurt? You would do an inspection, look at the ankle, look at swelling, look at bruising, look at all this thing. In other words, you're doing an evaluation. That's what we need to do with muscle cramps. Muscle cramps are not a normal physiological response to exercise. And so we need to treat them like an injury and do a full evaluation of those people. But where we've gone wrong, and I'm guilty of this as an athletic trainer too, because cramping oftentimes is self-treatable, we don't take them very seriously, right? Yeah. So an athlete like you said, right? When you go on your run, if you stretch your quadriceps and the cramp goes away and you finish your run, are you going to go see a doctor afterwards?
No,
of course not, right? Yeah. You're just going to keep self-treating yourself because you figured out the problem. I just got to stretch or whatever, and then it'll go away. But we treat this as a injury to the body. And so to figure out why you got that injury, we need to ask a lot of questions. And so the answer to the how do I prevent cramps is we got to figure out what your recipe is. And then once we figure out your recipe, we target that recipe with strategies.
Okay. Well, if someone particularly always gets a cramp in a certain area of their legs after a certain workout, would being more conditioned and adapted to that workout slowly reduce the risk of cramping in that specific muscle?
There seems to be some support for that idea.
Okay.
There's only one study, to my knowledge, that actually looked at strength training, for example, and cramp prevention. And what they showed was like the strength training did seem to help people. So again, I think we come back to the principle of if cramping, one of the major factors in cramping is exercise beyond what the body has prepared for, then essentially you have to practice like you play, right? And so when I get to my competition, my body recognizes this stressor as something that we've done before. And all of a sudden it doesn't become unaccustomed exercise. I'm used to this. And now I don't get cramps during the exercise competition. But yeah, you have to stress the body, how you play during competition. So it builds up that tolerance and acclimates to that stressor. And then hopefully that also helps with the prevention aspect.
Okay. Yeah, because I used to think that elite athletes have gotten to a level where they're so conditioned that they don't cramp anymore, but you still see it all the time, especially in like long course triathlon, right? And normally during the transitions or on the run leg, you see an athlete sitting there trying to stretch their leg. And I'm talking about the elites here. So yeah, it seems
and that's
like,
where I come back to, like, it can't just be fatigue, right? These are some of the most conditioned people on the planet.
Correct.
LeBron James, for example, one of the most conditioned human beings on the planet. You can't tell me he was not trying hard enough, like in those NBA
or not trained
finals,
enough,
right?
or not conditioned enough,
or
right?
not trained enough, right? And so it has to be beyond just fatigue, beyond just getting tired, or just beyond dehydration. It's more complex than that. And so those types of situations, like, you got to really dig into your athlete and your personal history to try and solve those problems, and just go beyond we need to train more. Because at the elite stage, these guys are already trained. It's got to be something else, something that we're missing.
Yeah. So when someone cramps, of course, we talk about stretching it. Is there any other interventions that would help relieve the cramp faster while someone is stretching? Should you try and shake it out? Should you? Sometimes when my foot is about to cramp, I kind of slam it on the floor a little bit, and it kind of helps it a bit. I don't know whether it really does, but you try and do some funny stuff to try and shake out a cramp. So what are some things that someone can do?
Yeah, so the stretching phenomenon is a really interesting one. So I did a study a few years ago where we applied gentle static stretching to people. And then we measured these things called Golgi tendon organs. And your Golgi tendon organs are like little receptors in your body that tell your nervous system to like relax. So they inhibit the nervous system. So the idea is that the reason why stretching relieves a cramp is when we stretch a muscle, we activate these Golgi tendon organs, and that tells our neurons to relax and become inhibited, and that stops the muscle cramp. And so what we did was we did a study where we said, okay, well, can we cause some inhibition of the Golgi tendon organs that then carries over after the stretching that might be preventative? And I'm sorry to say, it didn't work. So we did 3 minutes of calf stretching to people, and then we measured their Golgi tendon organ activity like immediately after we were done stretching, all the way up to like, I think it was 30 minutes after we were done stretching, and their Golgi tendon organ activity didn't do anything. It returned to normal almost immediately. And so a lot of times we see athletic trainers in the United States, for example, stretching athletes out before a competition, hoping that the pre-event stretching will carry over and prevent their cramping. But there is next to no evidence that stretching prophylactically will actually prevent cramps. Now, there is some interesting data. They're not well-designed studies with nocturnal cramping, that it seems like maybe chronic stretching, like 6 weeks of consistent static stretching, might help with nocturnal cramping. Again, the studies aren't super well designed, and certainly there's other things that are happening in the body when you use 6 weeks of stretching. For example, elasticity changes, muscle length changes, and so biomechanics changes. And so you get into the, does the muscle become overly fatigued because the biomechanical advantage is now different? So again, there's no evidence in athletes that prophylactic stretching works. Plus, my group, we did a study where we did the Golgi tendon organ study, but we also induced cramps in people after static stretching and doing this more complicated stretching called PNF stretching. And PNF stretching is designed to target the neurological system. It stands for proprioceptive neuromuscular facilitation. but it's supposed to target the neurological system. And so we did both of these types of stretching compared to no stretching. And what we found is that people were just as easily crampable with static stretching and PNF stretching as no stretching. So it seemed that, doing some kind of stretching, again, these are hydrated, no exercise, no electrolyte loss people. And it didn't seem that it was prophylactic whatsoever. But from a treatment standpoint, stretching is your go-to treatment. So if you are actively cramping in your calf, then you need to bring your toes up, dorsiflex your ankle, and that will relieve the cramp. But from a prevention standpoint, stretching doesn't seem to be the trick.
Okay. Would any of those topical sprays or creams help when you are cramping?
Unlikely.
Okay.
The skin is a really tough barrier to get any kind of chemical or nutrient through. I mean, think what would happen to your body if anytime you got something on your skin, it got into the muscle or into the bloodstream very easily. And so those topical sprays, oftentimes they give you the sensation of cooling, or they give you like a pain analgesic effect. And so in theory, they might help, because I believe pain is one of those factors that can cause cramping. Like you get into this pain, cramp, pain kind of cycle. And so if you can stop pain, maybe you can, stop the cramping. But usually those sprays don't go deep enough to actually impact the cramping muscle in and of itself. So usually if people are actively cramping, what I would say is, stretch them first, relieve the cramps first, then get them to the sidelines or get them out of the athletic contest and try and figure out, okay, what's going on? How did you prepare? What is your recipe for cramping? And then try and give them that. Or if it's an actual athletic contest, my goal as your athletic trainer would just be, how can I get him through this contest? And then after the contest, we're going to work on restoring muscle glycogen, restoring hydration, restoring rest, working on sleep, all of those things that are in your recipe to help you fully recover. But once you cramp a first time, like we mentioned before, you're probably going to cramp a second and a third. And it's not going to be until you stop exercise that we're actually going to be able to correct the imbalances in your body and try and stop that for the next day.
In a really terrible situation, I'm going to add a worse situation to the conversation. So in a terrible situation whereby your calf is cramping and the front shin muscle is cramping, so both sides are cramping, and you can't stretch one side because you are shortening the other side. And this happens to me a lot of times. What do you do?
Yeah, at that point, I would
scream in pain.
Scream in pain. So I would say, focus on the largest muscle first, right, which is usually in that comparator would be the calf or your triceps surae, your gastrocnemius, soleus, whatever is cramping. Because again, usually my perception is that the larger muscles, because there are more muscle fibers, more nerve endings, more pain nerve endings, that's what's causing you the most pain. So if I can relieve your calf cramp first, get that to stop, I can at least hopefully reduce your pain enough that then I can start working on your anterior tibialis or your anterior shin muscles. And so maybe it's a combination of kind of alternating back and forth, or just finding a position to put your foot in that seems to be comfortable for you and help with both of those things.
Okay. You talk about glycogen replenishment. So is there anything that someone should do after exercise, assuming they didn't cramp in the session, but they are a cramper like myself, that they should do post-exercise that would help them prevent onset of cramps in future training sessions or exercise?
Yeah, so this is a great question again. So again, we come back to the principle, we got to treat people as individuals, right? Like your sweat rate's going to be different than mine. Your nutritional needs are going to be different than mine, just based on our differences in body mass and our physical characteristics, exercise intensities, those types of things. And so I would tell people, start with knowing yourself first, right? Like, what are you training for? Are you just training to be healthier and those types of things? Then if that's the case, you probably don't need to run at an intensity that probably puts you into the cramp zone, right? But you have to know yourself. So if you start tracking like your exercise intensity, your duration, the environmental conditions, like I said, answer those questions in that table that I published, so you can at least try and identify, these are my causes. So if I avoid these things, or if I focus on these things, I might be able to help myself prevent cramps. I think you'll have a better approach. And so knowing yourself first is, I think, the most important thing. And so know what your dietary needs are. And there are certainly, fitness trackers and diet apps out there that you can see, like, how much carbohydrates do I need, how much protein, how much fat. So looking at your diet, looking at your sleep patterns, and there are tools and apps out there, like you can wear those rings that track your sleep. And so the answer to that question is nuanced. And, find a scientist that doesn't tell you something is nuanced, right? That's what people hate about scientists but it's nuanced, and it's nuanced for you, right? So understanding, like, what is my goal? What am I working towards? Like, if you're working towards an ultra marathon or a marathon and cramps always hit you like halfway through your training, okay, well, then we need to focus on, okay, what is your exercise intensity at that point? What does your training load look like? How much time do we have between now and your competition? Like, do you have gait or biomechanical things? There's some research out there that shows we can maybe prevent hamstring cramping by training your glutes. And so offloading some of the work that the hamstrings do by having the glutes do that during running or exercise has been shown to help some people with muscle cramp prevention as well. And so the question of what do I do? How do I attack this problem is very nuanced. And we need to try and figure that out for you, to figure out, like, what is your goal? What is your diet? What is your sleep like? What does your exercise parameters look like? And then once we have all this information, then we can start playing around with different things and figure out how can we help you.
Okay. All right.
And if you would like me to help you with that or help you through that process, I'm happy to do that as well. I have a side consulting business where I've helped professional athletes and teams work through this process to try and figure out, like, how can we prevent cramping in our team? Because, we get to the end of the season, this is the most important time, but like half of our team is cramping. And so if any of your listeners are interested in having those conversations, please reach out to me. I'm happy to help those mechanisms too.
Yeah, I'll put a link in the show notes for sure to that. A few final questions as we start to land the plane. If listeners remember only one thing from this conversation that will save them the misery of muscle cramps, what should it be?
Ooh, good point. I would say, again, it's that know yourself.
Know thyself.
Right?
Yeah.
It's know thyself. And so, again, the body adapts to the stress that you place on it. And so if you kind of start with that principle, anything that you do outside of that principle might be a trigger for why you cramp, right? And so if your body is used to getting 8 hours of good sleep, and then you have 3 hours of sleep on one day, and then you cramp. Again, that is a stressor on your body that it's not used to, and that may be something related to why you cramp during that exercise session. So you got to understand yourself first. Understand this is a complicated phenomenon that you're trying to solve, and then give yourself some grace, right? You're going to try some things. You're not going to be successful. You're going to try some other things that might be successful. And so as you kind of know yourself and know how your body adapts to those types of stressors, I think you'll be much more successful from a cramp standpoint.
Okay.
So know yourself first.
And what is the biggest mistake you see people making when they experience cramps?
I would say trying anything and everything. I've seen, for 20 plus years, I've been giving talks like this all over the world. And I've had people tell me, what about antacids? What about tonic water? What about pickle juice? What about bananas? Like, there are so many different concoctions and potions and lotions and creams and all the things out there that are guaranteed to work, right? And so again, I think it comes back to there's very little data to support a lot of these things. And so before you start rubbing or drinking or doing something crazy, like, know yourself first. Like, first figure out like your own recipe for cramping, and then we'll start trying solutions based on those things that we find. But yeah, don't just start putting things into your body that you're not comfortable with, or that might not be good for your overall health. Like I said, the first two questions to try and figure out like what your recipe for cramping is talk to your doctor first, get a good health screening to make sure that we're not trying to fix a more complicated problem, or that you don't have a more complicated problem first. Because if your cramping is due to hypothyroidism, but you've never had your thyroid tested, well, that might solve your problem, right? So We just created a more difficult problem when it was really your thyroid all along. So first step, we got to make sure that you're healthy, truly healthy. You don't have some other more difficult general medical condition that you're trying to solve first. And then after that, it's now let's figure out your recipe. But yeah, certainly, don't just start trying things without doing your homework first. So again, we got to treat muscle cramping like an injury, and every injury evaluation starts with a medical history, asking lots of questions, trying to get data, trying to figure out why you got the injury in the first place. And then we start treatment. Nobody would go to a doctor with sniffles, a fever, and a headache and be okay with their doctor being like, I've seen this before. Let's try chemotherapy. Like, we'd be like, don't you want to run some tests? And the doctor would be like, oh, no, I've seen this a lot. Trust me, it's cancer. Let's try chemo. Nobody would be okay with that. Same thing with muscle cramping, right? We got to get data first, and then we start treatments. Don't just start the treatment right away and start spending a bunch of money on these concoctions or potions before you understand what your major problem is.
Find out the root cause, yeah.
Exactly.
Yeah. My final question for you, Kevin, is what does endurance mean to you?
Well, as a scientist, there's 1,000 ways to answer that question, right? And define it from an exercise intensity standpoint, from a psychological standpoint, social aspect. Man, what a great ending question. Endurance to me is oftentimes just the ability to persevere, right? So for your listeners, for maybe students, for professionals, right? Perseverance is oftentimes that attribute that is almost undefinable, right? Life is going to hit you with all kinds of challenges and complexities. And so endurance for me means being able to get up again, try again, fail again, and just wanting to keep on going.
Kevin, thank you so much for a painful conversation that was so fun to have.
Well, thank you so much for having me again. I enjoyed this.